So welcome everyone. Welcome to this AIA East Bay Committee on the Environment special event. I'm Alice Sung, co-chair of our COAT, and am pleased to be here with Kira Gould, writer and consultant and communicator of all things COAT, really, at the national level for many years. Good to see also our San Francisco AIA COAT members. I see Charlie. I don't know if Mark's on yet. This is also co-hosted by SFAIA COAT, so thank you for that. And today, Kira will be moderating this event, Visual Delight in Architecture, Daylight, Vision, and View, with our guest, Lisa Heschong. And before I get into the introduction for Lisa, I'd like to invite attendees to feel free to put questions you have for Lisa in the chat as we go along. So those will be moderated maybe halfway through the hour, and hopefully we'll get a lot of meaty questions from you all. So Lisa Heschong is an architect, researcher, and fellow of the Illuminating Engineering Society, IES, and she was founding principal of the Heschong Mahone Group, a building sciences consulting firm in Northern California, as most of you probably know. At HMG, Lisa led the research team that found a correlation between daylight in classrooms and improved student performance, and daylight in office worker productivity, as well as retail sales. To my knowledge, her seminal research, Daylighting in Schools, over 2 decades ago, built the foundation for daylighting and views all of the credits in green building rating systems, such as LEED, and in particular, the Collaborative for High Performance Schools Green Building Rating System, known as CHIPS. She is also author of Thermal Delight in Architecture, which some of you may know, which is considered something of a cult classic in our green building circles. And her newest book, Visual Delight in Architecture, Daylight, Vision, and View, was published this year by Routledge. It explores new findings on the psychological or physiological, cognitive, social, and cultural importance of daylight and view in our everyday environments. Lisa has taught coursework in sustainability and green buildings at UC Santa Cruz. She is now a member of the advisory board for the Neutra Institute for Survival Through Design. And I think Kira's going to drop some of that information into the chat. And they're currently working on a variety of healthy building initiatives. Now, we might not realize it, especially some of you, maybe younger folks, but Lisa's work has profoundly influenced the Green Schools movement and the green building movement more broadly. For me, her teachings are really personal. I first met Lisa and her daylighting in schools research through my work leading a project team on the Chavez Education Center here in Oakland. That was back in 1999 to 2003. And I attribute almost everything I came to know about natural daylighting and designing of CHIPS rated schools to that first meeting. And in large part, all of my design work for schools especially has been actually founded on the principles of good daylighting and natural ventilation and energy efficiency that I think was formulated from my relationship with Lisa and her team. So 20 years later, here I am, pleased to introduce you to my friend and mentor, Lisa Heschong. Lisa?
Well, thank you, Alice. It has been a pleasure working with you all these years. And I've prepared a very brief presentation, hopefully by way of seeding the conversation today. But I'm hoping that this is really an opportunity to start a dialogue on especially the issue of view, as you'll see. So put those questions in the chat, and Kira is going to try to sort through them and figure out how to turn that into a dialogue. We can't easily speak back and forth with this many people, but I'm really looking forward to the conversation. Shall I launch?
Yes, please do.
Okay.
So we're going to go into share screen mode.
Okay. So, as Alice mentioned, I've spent a very large portion of my career working on daylighting and human factors in buildings. And more, I became convinced that we were leaving an elephant out of the conversation, which was the importance of view. In our early studies, we thought of view as a confounding factor that we needed to control for. And then we very quickly began to get even stronger signals from our research that view was equally important to daylight illumination, if not more so. So moving on. This talk is really focusing on some of the new ideas about view that are evolving. And I think we all know that real estate agents know the value of view. View can add millions of dollars to a project. Condominiums that face a beautiful view can go for 5 or 10 times the value of the exact same condominium in the exact same place, but without the view. It's a huge financial leveraging point, but why? Why are people paying that much money for view? They're paying more for view than they are for the location in the building. How is that possible? So starting from that question of, really what's going on, I think we also have to ask the counter question, which is, does the absence of view affect people? What happens if we live without view? People live and work in basements for large portions of their lives. And there are a lot of people both in their homes, but especially in their work environments, which have no access to view, or the schools that Alice and I went to in Los Angeles that had no views. So is access to view an equity issue? And is that something that the architectural world really needs to pay a little closer attention to? And I would argue that yes, absence of view has sort of knee-jerk responses from people. When I've done lots and lots of interviews with people asking them about their workspace, and if they don't have a view, they kind of go, I just feel like I'm in a prison over and over again. That's sort of the response, that being in a space without a view, especially if it's involuntary or not necessary for the process of your work, makes people feel bad, makes them feel like they're in prison. And there's further sort of psychological suggestions that it induces passivity. It tends to constrain our movement. It tends to constrain our sense of agency, because movement is one of the main things that we have control of in our lives. And there's this sense that we don't have freedom of movement without that view access. So we also need to really focus on the premise, which I'm sure you've all heard, that research has shown that North Americans spend over 90% of our lives inside of buildings. This is cradle to grave, from birth to death. Of course, we spend a third of our lives sleeping at home, right? So you're a good part of the way there, but the reality comes out that on average, we spend slightly less than 2 hours a day outside. And children spend about 9 minutes more. American children spend about 9 minutes more than adults. This is shocking. I was just reading a research paper from Norway where the average preschool child there spends 5 hours a day outside. Americans don't even come close. So essentially, we are an indoor species, and the design of our buildings creates the habitat that we live in. And there are lots of organizations, as you well know, that have tried to bring healthy buildings into a set of specifications for how we should be designing. So we're all living in a time where there's large consensus that we want to live in healthy buildings. So that's where we operate, that's where we spend the majority of our time. But does healthy buildings, biophilia, connection to nature, does that mean just a mural on the wall, like in this photograph? I mean, how artificial can we create that sense of connection, and how artificial can our healthy buildings be? Or do we really need a deeper connection to the real thing? So this is sort of the launching point for this premise. And as Alice has said, I've spent basically the last 3 or 6 years, depending on how you count, trying to do a deeper dive into the importance of daylight and vision. And the result is this recently published book, Visual Delight in Architecture. It's a lot bigger than Thermal Delight in Architecture, so if you're expecting a little book, no, it's kind of thick, but it uses the same structure. And it starts with the sciencey stuff, looking at cognition and cellular biology and what we have learned recently in terms of circadian stimulus and how that affects our health and well-being. It then transitions into perception, which is really focused on the individual and how we experience daylight and view. Motivation looks at social behaviors and emotional connections and the historical structures that we've used in our cities and building types to either promote or demote daylighting in view. And then the final part looks at culture and what I think of as transgenerational information, how we incorporate this information into the values that we pass on through our cultural priorities. Today, I'm going to really focus on the top level prediction and just touch very briefly on a few subjects so we can keep moving. I've put together this little mandala to help organize some of the topics that I typically cover, and to keep things short, I'm going to just talk very briefly about these three. I've tried to compress things as much as possible to keep this intro short and hopefully leave time for discussion. So another important key piece here is that we need to stop thinking of our eyes as cameras or as an extension of our brains. They're actually part of our brains. They come from the same neurological tissue during embryonic development. They have the same structure as the neocortex, and they're simply a little piece of brain that's been pushed out of our skulls for remote sensing. The eye, importantly, provides vision, but within the last 20 years, really since 2001, we've learned that it's extremely important in terms of circadian signaling and the biological clock, and helping our bodies and our brains keep track of timing, right? So there is just this little diagram down below of the eye, which you should recognize from your high school textbook, and then a blow up that shows the rods and cones in the back that do all the visual sensing. But at the very front of the tissue are the retinal ganglion cells, the RGC up here, which were originally thought to just be connective tissue. But it turns out that no, they're actually doing quite a lot of the cognitive processing of this visual information, and that there's a certain group of them, which are referred to the IP-RGC, the intrinsically photosensitive retinal ganglion cells, quite a mouthful, that are uniquely sensitive to blue light and provide very important input to the brain in terms of telling us what time of day it is and how much time has passed. They perform very differently than the visual sensors. And so the last 20 years in ophthalmology, neurology, even electric lighting has really undergone a revolution in terms of understanding how these are affecting us. So here they are, the IPRGC. So one of their peculiarities is that they are uniquely sensitive to blue light in the 460 to 480 nanometer range. A lot of work has gone into understanding that sensitivity. They also take a much longer time to fire. So whereas the rods and cones are very instantaneous, the IPRGC are averaging information over a much longer time period. Turns out that their peak sensitivity is also the peak intensity of all forms of daylight. So this graph down below, the dotted line shows you solar radiation outside of our atmosphere, which peaks at 480 nanometers. Solar radiation, sunlight at sea level, which also peaks at 480 nanometers. And just the diffuse sky radiation, the blue sky, which also peaks at 480 nanometers. So here's our visual sensitivity system, and that peak sensitivity of these IPRGCs it basically is telling our bodies it's daytime, the sun is out, the sky is blue, time to get busy doing all of your daylight type activities. It turns out that our exposure to that blue light is also the primary signal that we get from looking out windows at a daylit environment. So if you need a strong signal to tell you it's daytime, the best thing to do is to go outside and be under the sky. But next best is to look out a window, and that signal is easily 10 to 100 times stronger than anything that's going to be provided by electric lighting within the space that you're in. And so I argue that in terms of circadian stimulus, if people have access to a window, not only is it more intense, but it's also more interesting. It's actually where people spend most of their time looking if they have the opportunity. So another revolution that has been going on over in the field of neuroscience is the use of fMRI machines that help to map the activity of the brain. Also 20 years ago, a new pattern of brain activity was identified when they would put people in an fMRI machine and ask them to recite poetry, sing a song, or do a math problem. They would see one signature for the task and then a separate signature that kept recurring, regardless of what task it was. They came to call this the default mode network because they thought, well, it's the default, right? If you're not doing a task, it's the default. And it was assumed that this was the resting state of the brain, that somehow when you weren't on task, it went to resting state. But then people began to realize that the resting state was at least as active, if not more energetic, than the task. So what was the brain doing if it was working so hard during this resting state? Studies done at UC Santa Barbara have found that the more time people spend daydreaming, the larger working memory they have, the better memory consolidation, and most interestingly, the better incubation for creative problem solving. So that's really when your brain is processing information and coming up with new solutions. Well, that's a pretty important task that are highly connected with how we use windows and views. Again, I tried to really compress this, and I do want to get to the questions if we can. But another key piece is what is thought of as cognitive mapping that helps us orient all of our activities, all of our mental activities in time and in space. So window views help us understand where we are and when we are. It turns out that a lot of this processing is done in the hippocampus. The hippocampus is at the very center near our brain stem, a very ancient part of the brain, and it helps us navigate, understand where we are in space and where we are in time. And interestingly, those IPRGCs also connect to the hippocampus, so helping to create that sense of time. Here's a study that was done by Russell Epstein at the University of Pennsylvania, another psychologist who used fMRI machines in a very clever way. He brought in students from 2 different campuses and showed them photographs of buildings on their campus or the other campus, inside and outside. And so if they had been in the building, all of the photographs of that building, whether from the inside or the outside, registered with a single fMRI fingerprint. It was a place. Whereas if they had not been on that campus, they had not experienced those buildings, photographs just looked like any other picture. So it was just a 2D image photograph. They weren't integrated together. So this cognitive map, experience of space, our brain is trying to knit together reality and make sense of it. And we can see that in neurological signatures. That's another function that views help us to do, is sort of knit our world together and understand it better. I'm going to skip these very quickly. These are different ways of thinking about the importance of view. I would argue that central to our valuing of view is understanding that we're looking at something where we could go in the future or where we have been in the past. And so that projection of ourself into the view becomes very important in terms of our emotional connection to it. Then I put together this list, which I'm mostly going to let you review and read, in terms of all the questions that a designer really needs to answer in terms of understanding how a view is going to be operating in the building that they're working on. Starting at the highest level, which is, why is the view interesting? What is the social priority for the occupants to have that connection and that view? So that's at a very large urban scale, down to very specific in terms of how do you balance visual comfort? How do you achieve just high visibility and high visual comfort from that experience? I think it's also really important to ask the question of who can access the view and what kind of permissions they need. This came up when we were working on a code proposal for ASHRAE 189, and the alternative to having view available to all workers was, well, we'll put it in a break room, or it's in the lobby and in the lookout up at the top of the building. But then you start realizing that there's limits on when people can go to those spaces, who can go to those spaces, that there's social structures that prevent those being readily accessible to all the occupants. So it's not just the design of the building, but you've also got to think through what the potential operation might be. And so that's a really fast overview. I would argue that designing buildings with wonderful views is one of the greatest gifts that an architect can give to all the occupants of the building and future generations. And it's one of the best things that we do. So let's try to do some questions and see if we can keep it clean.
Absolutely. So I was thinking, we had a couple questions that people posted before, but neither of those people rejoined, I don't think.
And we've lost the chat, right?
Well, I captured the questions, but there is one that I wanted to throw out. And then if any of you that are on here now have questions, please post them. And we're a small enough group now, I can just ask you to verbalize it. But one I wanted to throw out a little bit, because we think there's a lot of people who are focused right now on building reuse. And I wanted to ask you if you could talk a little bit, Lisa, about how architects should think about daylight and views with respect to retrofits. Like what are some of the things that, I mean, because that's just such an enormous area, and it's in an area where we have less freedom, obviously, about some of these things.
Right. Well, if you're working on an older building, let's say pre-1950, good chance it was designed with large apertures and lots of access and narrow plates, and it's fairly easy to retrofit in terms of daylighting and view. It's the more modern buildings, certainly starting in 1950, but accelerating through the 2000s with buildings that are becoming ever larger floor plates, ever further from facades, narrow floor-to-floor dimensions, so that it's difficult to get adequate daylight and view into those spaces. So depends on how major a retrofit you're doing, but looking at taking chunks of the building out, certainly if it's a low-rise building, bringing daylight in from above is usually a huge opportunity. Adding an atrium into the center portion or a winter garden along a facade can provide basically crenulating the facade of the building to allow more access to daylighting and views. It's a geometric problem, and it's an interesting one to think through, and it's different for every building. So that's step one, is the geometry. Step two is looking at how to optimize layout inside of the building and making sure that people that spend the most time there have the greatest access to the daylight and view, that they are given priority, that the people who spend the least time there are presumably going somewhere else or going outside. And so you want the person working in the lobby to have a good daylight exposure. You want the maintenance person that's there day in and day out to have daylight and view exposure. And so relocating those activities out to the perimeter where it's available.
Right.
Then there's also the issue of retrofitting the glazing system and how to add additional controls to a glazing system that might not have had sufficient daylighting controls. And that's a whole list of design possibilities there.
Right. We are getting some interesting questions in the chat, and I think I'm going to ask Eric, would you like to read your question, ask your question verbally, or I can repeat it if you don't want to.
Sure. Thank you, Lisa, for the talk.
Hi, Eric.
So the thought here is about, it's kind of an impossible task of putting a dollar value on a view that can, feed into some sort of objective function when you're trying to optimize fenestration design and construction costs and all those kinds of things. Otherwise, your energy model tells you don't have any windows at all sometimes.
Yes, so I know. So the question is, can we translate it into a dollar value? For real estate agents, it's millions of dollars. It outweighs, in terms of value to the occupants, it outweighs almost every other part of the building. That said, in the study that we did at Sacramento Municipal Utility District with the call center, the people working in the call center who had the biggest access to view were processing calls 7% faster than those without an access to view. That additional 7% was worth half of the value of the building. So if all the workers had had that, the building would have paid for itself in 2 years, period. I don't know of anything that has a bigger multiplier than that. But we in America have become so accustomed to cost engineering every little detail that we do that we've sort of lost common sense in terms of what the priorities need to be for our buildings, and that the health and well-being of the occupants is the purpose of the building. Everything else, frankly, is secondary.
Good points.
Right. Well, and that does, I mean, for certain clients, particularly like a corporate client, the health and wellness of its, I mean, its people costs are much higher ultimately than its real estate costs. So those that quickly does translate overall to a meaningful bottom line number.
I mean, we found in Fresno, where we looked at view versus the cost of computers. And so it turns out that having a good view had about the same effect on student performance, math and reading, as having access to, I think it was 5 computers within the room. So then you look at the cost. What's the cost of the computers? What's the cost of the windows? Well, the windows are going to be there for 50 years. The computers are going to need to rebuy them 5 years down the road. And they also have a continuous maintenance cost. So all those costs need to go into that additional value of that technology upgrade, which people don't do.
Right. So we are running out of time. Ben had a question. Ben, would you like to articulate that, or shall I?
Yeah, I was just going to mute myself and show my face. So, yeah, thank you for the abbreviated talk. I really appreciate it. One of the things that I got from your talk and from other talks that I saw from you is that the windows are just more than just a facade. Basically, okay, the cheapest thing, that they're sort of carefully framed, and they serve multiple purposes. So my question is, when you turn around and you see all these all glass buildings, whether they are speculative office buildings or luxury apartment buildings, are they really going in the right direction? I mean, they're cheap facades. They go up quickly, and developers love them. But in terms of views and access to daylighting, I'm a little torn, because they do provide these killer views and expansive areas of glass, but I am still a little.
Well, you're absolutely right. A glass facade is the cheapest and easiest facade to do and requires very little thought. We know that it can have profound negative energy implications. They're frankly not that easy to live in. People tend to, or designers tend to lose the subtlety of solar control and privacy control and all those other things that really make views work. So, I'm not saying give that all up. No, that all has to go into the art form. We have to appreciate both how important the view is and how to manage it for all these other priorities. It's not rocket science. We know how to do it, but it takes a little bit more thought than just a slapdash approach. And that's really what I'm arguing for.
Right. So we do have a few more questions, but I think we are getting very close to our time here. And I have one that I want to actually ask, because it's something we didn't get to one of the most recently when we spoke, Lisa. So it has to do also with your conclusion. There was a paragraph in the conclusion that really struck me as quite powerful. And you mentioned this a little bit in the slides today, but where you talk about how views enhance lasting emotional attachment to place, and this connection, including a connection to the history of place and to the promise of continuity with the future, which seems to me exactly the kind of attachments that we need more of right now as we face this very uncertain future for a lot of reasons. And I'm wondering if you could talk a little bit about how issues, and all of the issues that you're discussing in visual delight and designing for these, how those relate to the climate crisis. You just mentioned it a little bit with the glass buildings and the energy implications of some of those, but I wondered if you might be able to connect it a little bit just to the climate questions and that broader, that's a context now that we're all designing within, right? So I'm just looking to make a little link there.
Well, I don't know if I can tie those two together. I mean, certainly the climate crisis coming at us argues that we need interior spaces where we can happily live and retreat, even when there's a fire raging nearby, you know, that we need resiliency, that we need buildings that function after there's an earthquake or a power outage. We need that sense of continuity, that life goes on in spite of all these insults that keep coming at us. So that connection, that my place, I still have that connection even while I'm sheltering in place is important. That sense of continuity is important to all of us emotionally, I'm sure. How that's going to translate into the buildings that we are creating in the future, I think of it more as an urban design issue, and how we continue to try to mold our cities to enable more people to have views and connectivity to their city, that they feel that they're very much a part of it. There was this one quote from a real estate agent in San Francisco saying, you know, my rich clients, they want a view of the Golden Gate Bridge because then you really know you're in San Francisco. It's like, you need to have a view of something to know you're in San Francisco. But it's emphasizing this point that visual connection has a really powerful emotional push to it. And everybody wants that sense of, yes, I'm here. This is my place. This is where I live and work.
Yep, absolutely. That is the end of our hour, our disrupted hour that we have had. Lisa, thank you. And thank you everyone for coming back. I really appreciate it. And particularly Lisa for being able to pick right back up. And that was a fun new experience.
It was new. It was definitely different.
But we really appreciate all of you coming, and we maybe we'll do a redux anyway, just for fun, because that would be, I think there's a lot more to talk about.
And here's my email, and you are welcome to email me with questions, and I hope that we can continue a deeper conversation.
Absolutely. Thank you, Lisa.
Okay. Bye.
Thank you.
Thanks, Lisa.